Welcome back, students. So today I will discuss the remaining part of this radioactivity, radioisotopes and nuclear fissions and the fusions. So basically the radioisotopes, we have very similar of very quite known of these things, radioisotopes like carbon isotopes, sodium isotopes, phosphorus isotopes, cobalt isotopes, iodine isotopes. So these are the isotopes. Basically they are called the radioisotopes. So what is this radioisotopes? Basically radioisotopes is a kind of elements can be prepared by the bombardment of the neutrons over it. That is called the radioisotopes. Means when the normal elements are subjected to neutron bombardment in the nuclear reactor, basically the nuclear reactions are being placed in nuclear reactors, and the nucleus captures one or more neutrons, and this makes the nucleus unstable, and hence they emit the kind of nuclear radiations, and the such artificially made elements are called radioisotopes. Okay, so radioisotopes means substance are being bombardment, or you can say that the absorb or capture some neutron, extra neutrons from the others. So this makes the unstable because the substance no need the neutrons, and if the tendency to captures the neutron, that time it makes the very unstable. And after this instability, they emit some radiations, and this is called the substance which can by this process can be made, they call radioisotopes, and the substance can emit the this kind of radiations are called the radioisotopes. So we have some common radioisotopes and their uses you have to know, because these isotopes can be used in many times, in many situations, and many other organizations as well, many other our different kind of purpose. Like the carbon isotopes, basically it is used for the age determinations, very old age substance age determinations. Like the sodium 24 is a very important, because it used the circulatory disease in the human body. And we have used the phosphorus, it is used for the cancer, basically the bone cancer treatment. Cobalt is used again the cancer, curing the cancer, because the many kind of this kind of radiations can be effect on the cells and can destroy the unwanted cells. That's why it can be used. Iodine 31 specially used for the thyroid test, thyroid gland cancer. If somebody having a patient of victimized of this thyroid gland cancer, so that time iodine 31 can be used, and by this uses the many of the cells can be damaged, the unwanted cell becomes damaged. Ordinary is used by the process of called chemotherapy. Okay, you don't know, I think. So this kind of treatment has been used by these radioisotopes. Now coming to the point, what are the harmful effects of these radioactive radiations? So see students, harmful effects, if I say the harmful effects of radioactive radiation, it is much more, because if somebody having victimized of this harmful radiations or nuclear radiations, the person can be severe disease, can be mortalities come, means death. Okay, sometimes it lead to cancer also. So that is very important. That's why many of the means this kind of radioactive plant, in case or sometime where the radioactive substance can be prepared, medicines can be prepared, that kind of organizations, along with some of the places where the thermal power plant also, where the radioactive substances can be dealt. So that time the persons who have to deal these things, they should be very well prepared, as well as they have some safety equipments along with, because until and unless it is, if not measured the safety, so that is very dangerous for that person health. So it is very important. Okay, and otherwise some of the useful effects of the radioactive radiations also, like this useful effect means this kind of radiations can uh, damage the unwanted cells, like the cancer therapy can be used. Some kinds of preservations purpose we can be also used. The bacteria can be killed by these harmful radiations. So many of the useful effect and adverse effect also is there. So now coming to the point, the very important nuclear energies. So nuclear energy can be broadly classified by two types, that is the fusion and the fission. That is, one is called fission and the another is called fusion. Basically the fission process is the splitting process, the splitting of the nucleus of heavy atoms to form a lighter nuclei, called the fission. Suppose I have one nuclei and I have fission it, means I have break it. So it is called the fissions, means splitting of the heavy types of atoms into a simpler, very small nuclei atoms, called the nuclear fission. Whereas the nuclear fusion is the process by which the two or more small atom can be joined with very drastic condition. Drastic condition means very high temperature and pressure to form a stable heavy nucleus with the enormous heat energy is released, called the nuclear fusions. That is very important. Nuclear fusions, nuclear bomb making purpose you can be used. Okay, so because the nuclear fusion, some of the nucleus has been joined, two or more small atoms joined and make a heavy nucleus, but it's such, this process is such a very tough process. With drastic condition this can be lit, very high, extremely high temperature and pressure is needed. Okay, you don't know. However, the fusion of hydrogen atoms, suppose I have joined two hydrogen atom, it form the helium nucleus. In this particular process 10 million degrees Celsius, 1 million times atmospheric pressure is required. So a lot of pressure, lot of temperatures, and after that this kind of nucleus will be prepared, and when the formation of this product, that time the high energy will be released. So this process actually called the nuclear fission. Okay, so after this nuclear fission and the fusions, one thing is remain, that is the nuclear power plant. So this process, basically if you used so many kind of energy you can produce by this nuclear fusion process. So this particular process, wherever this process can be made, this instrument is called the nuclear reactor. So this is the picture of this nuclear reactor. Basically this nuclear reactor produce the is having some some basic part of peripheral parts of this, but I will not go in these details of this. I will just tell the mechanisms of this, how to do work. Basically the nuclear reactors having provide the some large amount of heat. It supply the large amount of heat. How they produce the large amount of heat? Because the nuclear fission, most of the nuclear energy obtained by the nuclear fission, and the nucleus of the atom, suppose like your uranium or plutonium, and they split up and designed a machine called the nuclear reactor by slow moving neutrons. Already I have discussed these things. And after that this nuclear reactor produced the enormous amount of heat, large amount of heat produced, and this heat energy again it combined with a turbine, run with a turbine, and with some electric generator also being involved with this. When the turbine rotated and the steam of this steam energy can be converted into the electric energy, and this way the nuclear nuclear reactor has been worked in many of the thermal power plant. many kind of, sorry, not thermal, it is a nuclear power plant. So in India also some of the nuclear power plant is there, like uh, Kalapakkam, Tarapur power plant, nuclear power plant is there. So what are the safety actually measure for the nuclear plants? So safety is very important, because whenever the person is work on these particular plants and deals with radioactive elements, they have to have ensured that some means safety is there or not, because safety is first. Okay, so that time they will handled with a lead lined aprons. Lead lined aprons is protect the radiations, and special type of goggles or eye protector can be used. Some special type of film badges can be used, and these badges can be absorb the radiations, and the periodic medical checkup is needed. After that, that person is particular person uh, is overexposed by the nuclear radiations or not. So they have to ensure. So this is all about your radioactivity topic. I think this is the new topic has been introduced in your book. Last time this is not in your books or syllabus, but this time has been included in your standard. So Bidi, you are fortunate, you have learned a lot of things. So this much I think enough for you, your standard. So you have to go through this video and you have to learn everything, and I will give the exercise part also. Okay, thank you.